We're going to look at factoring when a is not equal to 1. Number one thing to remember is that you always, always, always look for a GCF first. You'd be surprised how many times that's going to happen and you're going to overlook it, and then the problem's going to be much harder than it should be. Okay, I'm going to start with 3x squared minus 16x plus 5. Many of you learned the box method. If you learned guess and check, that's great. Regardless if you use the box or guess and check, I recommend that you start with the x first. A is 3, C is 5, so 15 goes at the top. A is 3, B is negative 16, C is 5. AC is 15, B is negative 16. So what works is negative 1 and negative 15. Okay, those of you who learned the box, first box, first term, 3x squared. Last box, last term, that's 5. And then the order in which you put the negative 1 and negative 15 doesn't matter. So I'm going to put negative 1, the variable is x, and negative 15x. Okay, the GCF here is x. Ask yourself, something times x is 3x squared, that's 3x. Something times 3x is negative 15x, that's negative 5. And here we're going to have negative 1. Find the GCF of any row, any column, doesn't matter. When you're done here, you get 3x minus 1, x minus 5. Another method you may have learned is called splitting the middle term or grouping. So I'm going to split the middle, 3x squared. So essentially I'm doing the box, but I'm doing it like in a row. Negative 1x, negative 15x, plus 5. So you'll notice essentially this is the same as the box. Grouping is going to be a super, super helpful method as you go through your factoring life. I'm going to group the first two terms and group the second two terms. I put parentheses around the first two terms, parentheses around the second two terms. And I'm going to find the GCF of each group. The GCF between 3x squared and negative x is 3x. And when I take that out, I'm left with x minus 1. The GCF, remember I told you to take out the negative. If the first term is negative, take it out. The GCF between 15x and 5 is 5. And that leaves me with 3x minus 1. And I made a mistake. The GCF here is just x, not 3x. My mistake. And so the 3 should be here. Sorry about that. And I knew I made a mistake because when you group, this must match. Whatever's in the parentheses must match. So I'm going to take that out. 3x minus 1. It's what they have in common. And if I take out 3x minus 1, I'm left with x minus 5. Same answer either way. Grouping is a good method to know. Okay, how about something like negative 2x squared minus 15x minus 7. All these negatives are icky. I'm going to factor out a negative 1, which is going to leave me with 2x squared plus 15x plus 7. A is 2, B is 15, C is 7. AC on the top, 14. B on the bottom, 15. So what multiplies to 15 but adds to 14? I think that would be -1 and -14, but that doesn't work. I'm gonna, oh, sorry. How about 1 and 14? There we go, just kidding. 1 times 14 is 14. 1 plus 14 is 15. I'm gonna make the box. First box, first term, 2x squared, x, 14x, 7. First box, first term, last box, last term. GCF here is x. GCF here is 2x. GCF here is 7. Notice 2x times 7 is 14x. GCF there is 1. So you're left with 2x plus 1, x plus 7. But don't forget the negative sign that you took out in the beginning. And yes, you do need to take that out in the beginning. The other alternative is to do it by grouping. So that negative in front, 2x squared plus 15x plus 7. Split the 15 to make it 1x and 14x. Group. So again, the GCF for each group. GCF is x. That leaves you with 2x plus 1. The GCF is 7. That leaves you with 2x plus 1. 2x plus 1's match. Take that out and you're left with x plus 7. And don't forget the negative that we took out in the very beginning. Let's look at 6x squared minus 4x minus 2. Don't go straight to the box. These have a GCF. Take out the GCF, which is 2. There is never an exception to the GCF rule. I'm going to hold off on the 2. A is 3. So AC is -3. B is -2. So what multiplies to -3 but adds to -2 is -3 and +1. So either make your box or group. I will do this problem by the box. I'll do the next problem by grouping. First box, first term. Last box, last term. -3x. Just put an x on it because that's the variable. GCF is 3x, x, 1, -1. So the 2 that you pulled out to begin with, 3x plus 1, x minus 1. The order does not matter. When you multiply, order doesn't matter. So if you have x minus 1 first and then 3x plus 1, no problem. I'm going to do 2 more. Of course, this video is optional. You can turn it off whenever you'd like. Let's start this one. 16x squared minus 25. Those numbers are huge. A is 16, no shortcut. B is 0. C is -25. Okay, heads up. 16 is a perfect square. 25 is close, or sorry, negative 25 is close to a perfect square. Let's say you don't realize that and you go to your diamond, X whatever, and you get negative 400 on the top and 0 on the bottom. This is a clue to you. Negative 400 is a perfect square. Also a clue to you. Perfect square, perfect square, perfect square. It's called the difference of two squares. It's one of the most common factoring patterns. $16 is 4 times 4. 25 is 5 times 5. The difference here is we want negative 25. So one of them's positive, one of them's negative. Okay, one last example. $8x squared plus 10xy minus 3y squared. Double variable, so what? A is 8, no shortcut. A is 8, B is 10, C is negative 3. AC is negative 24, B is 10. Don't be fooled. I was like, oh yeah, 6 plus 4 is 10, but 6 times 4 is not negative 24. How about 12 and negative 2? It might take you a while to figure that out. I'm going to do grouping. So I have 8x squared minus 3y squared, however you want. Sometimes it's called splitting the middle term. The middle is 10xy. So I'm going to split it into positive 12xy and minus 2xy. The method you use doesn't matter. Group the first two, group the second two. It's just a different form of the box. GCF. So the GCF is 4x. Leaves you with 2x plus 3y. You better have 2x plus 3y, otherwise you made a mistake. They have a negative in common and a y. And sure enough, you get 2x plus 3y. If they don't match, you either made a mistake or your variables, your numbers here are wrong, or the problem is not factorable. You're left with 4x minus y, 2x plus 3y. That is factoring when a does not equal 1.